All right. Well, let's see if I can't figure out how to make this work. Good morning, good afternoon, good evening, depending on where in the world you happen to be. My name is Christopher Harrison, and I'm a senior program manager inside of academic ecosystems in at Microsoft inside of cloud and AI. And today, or again, this morning, this afternoon, depending on where you happen to be, what I want to focus in on is to take a look at two very common libraries that you'll be using when you get in and start working inside of data science, and that's going to be Numpy and Pandas. Now, I want to set some expectations right away just to make sure that we're all working on the same page here. And I want to highlight the fact that we're not going to be able to get real deep into NumPy. We're not going to be able to get real deep into Pandas. After all, we've got about an hour or so to talk, and there's really only so far that you can go in an hour. That being said, what I do want to do is to focus in on some of the more common components that you'll be playing around with when you get started inside of NumPy and Pandas. Now, everything that I'm working on inside of my little projects is actually based off of, there we go, a whole set of odds and ends that we have that we present over at the Microsoft reactors. And you can find out information about the reactors, you can find out information about all of our content and so forth by heading on over to github.com/Microsoft/reactors. And you can find the notebooks that I'm playing with here. You can actually go grab the big versions of them that are inside of there. And I'll also be pushing out the updated version, or sorry, the smaller versions that I'm going to be going through as well, so that way you'll be able to go back and access these on your own. Now, the tool that I'm going to use to work through all of this is a fantastic little tool called a Jupyter Notebook. Now, for those of you who've never played with Jupyter Notebooks, Jupyter Notebooks are a fantastic tool for the data scientist or really any Python developer at all that needs to just go in and play around and try different things. That one thing that you're going to notice about getting in and doing any form of data science is the fact that there's just a lot of trial and error. There's a lot of, well, let's try this model, and a lot of, let's try this to update the data, and a lot of, just different things that need to happen. And what's great about notebooks is they really do support that iterative approach, that what you're going to notice is that there'll be really nice abilities to write out a little bit of code, run that real fast, see what the results are. Run a little bit more code, see what those results are. Realize, oh, wait a minute, that's not quite working the way that I was hoping it would. Go back up and start all over again without having to rerun the entire application. So if you were working with something, say, like Visual Studio Code, which I do love, you'd have to really go in and do an awful lot of kind of architecture of like scaffolding and things like that. Notebooks take care of that for you. Now, I should make sure I caveat that. I should make sure that I highlight that inside of Visual Studio Code, it is actually possible to work with a Jupyter Notebook. So that way, if you're already a code fan, maybe you want to be able to put things into source control and things like that, that VS Code will really still be able to help you out and support you there. I'm just doing all of mine browser-based. Now, inside of a Jupyter Notebook, I do want to highlight the ability to go in and start creating brand new notebooks. So I'll just create a brand new notebook with Python 3. And then you'll notice inside of here that I can start punching out whatever Python code it is that I want. So if I go ahead and do the very classic hello world, and I run this, you'll notice that sure enough, it prints out hello world. Now, the way that I ran this is actually by using a very simple shortcut key of Shift-Enter. And what Shift-Enter will do is it will actually run that cell and then move to the next one. If there is no cell, then it will actually create one. Or alternatively, let me go ahead and just delete that cell. If you use a Control-Enter, then what that will do is it will run the cell, but then just stay on that cell right there. Now you're also going to notice right here, I've got this little in, and then there's that number 14. And that's actually going to become very important because that's going to show me the order of execution. It doesn't necessarily need to go top to bottom there. You'll also notice, and we'll actually see this a little bit later, there might be an asterisk in there, and that's simply showing me that it's running. And if there's nothing inside of there, like I've now got on my bottom cell, then what that's going to be indicating to me is the fact that that code has not run. Now, the other thing that I want to highlight real quick, and then we'll actually get in and start doing some demos here, is the fact that if I simply have some little, hello work, if I have some little bit of code that I've executed, and it just simply gives me back a value. So maybe I do like that hello world, or if I do like name equals Christopher, and then I just simply print name, or maybe Twitter equals Geek Trainer, and then Twitter. You'll notice that on the bottom of the ones that are marked as 17 and 18, that I ended this with just simply the name of the variable. So I just simply said name here, and I just simply said Twitter here. And what's going to happen inside of a notebook when you do that is it's just simply going to print out whatever that value is. And that's probably my favorite feature about Jupyter Notebooks, is that ability to be able to just run something, go, hey, I just need to know what's inside of this variable, and just print it out. And in fact, I do this constantly inside of a notebook, that I might be doing some bit of advanced work. I go, hey, I know I've got a variable. I can't remember exactly what's in it. Just type it in, and then away we go from there, and it will display out what's inside of there. It's a fantastic little feature, and it again goes back to what it was that I was talking about before when it comes to my my Jupyter Notebooks, is the fact that it gives me this wonderful ability to quickly see what's going on, to try different things, and so forth. So I could have modified that variable earlier, and now let me go ahead and reprint out what the new value is, and I can very quickly see that. So I love Jupyter Notebooks for exactly that reason. Now, let me come back over here, and I'm just going to restart my, my cell, clear out all my output. And let me focus in on the first of the two stars that we're going to be talking about today, and this is NumPy. NumPy is a handful of different tools that will help you out when you're working with large amounts of data. The big thing that NumPy is going to do for us is it's going to really enhance the way that a list or an array would work normally inside of Python, and it's also going to give us better performance. Now, the NumPy library is going to be available to you on most Jupyter Notebooks that you're going to be working with. If you happen to decide, hey, I want to incorporate this inside of a Python app that I'm building, then you can just simply install this by using Pip Install. I've already got it installed, but what I need to do is to import it in, and we'll do that right up at the very top by using import NumPy as NP. Now, a real quick note about that NP there. If you've ever seen me present before, you've no doubt heard me talk about the fact that I really hate 1- and 2-letter abbreviations, and that's still true. But I'm always a fan of going along with whatever the community standard happens to be. And the community standard for working with NumPy is to alias NumPy as NP. So I'm going to go along with the flow here, and I will always use NP, even again, though I'm not necessarily a fan of 1 and 2 letter abbreviations, and that's okay. So the other real neat little thing that you can do with Jupyter Notebooks is if you type out a variable that you might happen to have, or in my case, a namespace that I happen to have, you put in a dot and then you hit tab. What this will do is this will then print out everything that's available to you inside of that object or inside of that, that namespace like I have right here. And so it's a really nice way to go in and start to explore what might be available to you inside of a particular object. It's also worth highlighting the fact that we can actually get a little bit of help as well. And again, this is specific to Jupyter, by typing out something and then putting a question mark after it. So if I run that cell there of that mp.add and then put in a question mark, then what you're going to notice is that I now get a nice little help screen. And this is actually the docs that are part of NumPy. So if you're curious about how add works, you can go in and check everything out just by using that little question mark. And it's just a wonderful little tool that you can very quickly go in, see, hey, I don't know what something does, and just simply print it out. Okay, now, we've talked a little bit about NumPy, and you might be wondering, okay, well, what is NumPy really going to do for me? What is NumPy all about? Well, the main thing that NumPy is all about is an array. Now, for those of you not familiar with what an array is really just a collection of items. Now, in Python, we do have this ability already in play. We do already have arrays, and we do already have lists. But unfortunately, they don't necessarily support a lot of the advanced functionality that we might be looking for, and they're not always as performant as we might be hoping for. And when you're working in data science, it's really all about performance. So you're going to be working with large sets of data, and it'd be really nice to have some tooling that's going to be able to keep pace. I don't want to have to sit around and wait for 5 minutes just to try and process, say, 1,000 rows. It'd be nice if we could have something that's going to work a little bit faster, and that's exactly what NumPy is going to do for us. So if we start off by taking a look at a basic little list here, and we just simply create a list of a range of 10, so 0 through 9, then what we're going to notice is we just get a list. Just a normal Python list, nothing fancy here, exactly what we would expect. And if we loop through all the items inside of there and go to print out their type, what you're going to notice here is, as we might expect, that it's integer, 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 integer. Because after all, we put in a whole bunch of whole numbers there. We put in a whole bunch of integers. Wonderful. But one of the great things, and sometimes one of the more challenging things about Python, is its flexibility. So I can create a list with whatever data types it is that I might want. So I've got a Boolean, I've got a string value, I've got some form of a float, and then I've got an integer. And sure enough, I can create a list like that, and then what you're going to notice is the fact that it's going to store each individual item with its own data type. And this is problematic partly because then it can allow me to make mistakes that I might be throwing in a wrong data type, but it's also going to hurt performance because the list now needs to remember what all of the various data types are inside of there. So even if they're all integers, even if they're all the same thing, they're all consistent, it still needs to store that this is an integer, and 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 so forth. Hold on 1 second here. Do I have the ability to I don't. Shoot. Okay. That tool does not work in here. All right. I was trying to use a great little tool called Zoom It, and unfortunately it's not going to work the way that I've got my, my broadcast set up, but that's okay. All right. So here's our problem, is we've got all of our different items storing their own data type. So what I'd like to be able to do is I'd like to be able to set up a better list. I'd like to be able to set up a list where everything is going to be a consistent data type and only stored one time. And I can do that by calling this array function off of NumPy. And what the array function will do for me is it will create a NumPy array. And you'll notice here that I'm actually passing in the list syntax here. So this is going to take a list and convert this into a NumPy array for me. And so if I run this, what you're going to notice is that my output is that 14253. You're also going to notice on the output that it's telling me that it's an array. And the reason that that's happening is because of Jupyter Notebooks. The Jupyter Notebooks wants to display my data type, and so it's giving me that data type as well. Now, that's all fine and dandy with integers. But now let's talk about that next little block of code that we have here, where what you're going to notice is we're going to have a float. And if I run this, and we display the output, I want you to pay attention here to the 4, to the 2, and to the 3. And you'll notice that there's a decimal point after each one of those. And that's subtle, but there's actually a very big difference here. That what's happening is that each one of those is now being upcast into being a float. So it's taking all of those items, even the integers, and converting them all to be floats. So now everything in there is stored as a float, and my NumPy array doesn't need to keep track of the data type for each individual items. If I happen to throw in a string, it's now going to store all of those as strings. So that little U32, it's just a little Unicode marker there. And over here, what you're going to notice is those quotes that are around each one of those items showing us that those are going to be strings. Now, arrays will take care of that for us, but we also have the ability, if we so desire, to specify a data type. So if I want to force it into a particular data type, I could force it into being a float, or I could even force it into being strings if I so desire. Now, I want to mention that at this point here that if you have questions, by all means, please do speak up. There's a little thing about trying to broadcast at a lower level. Let me see if I can't figure out how to do that in 30 seconds or less. I don't have the ability to change that on the fly, unfortunately. Is everybody getting lag, or is it just the one person that's getting lag? Okay, cool. Okay, cool. And then the other thing that I want to mention, okay, fantastic. So it looks like for the most part things are working okay. The other thing is, actually, you know what, let me take 2 seconds here. I'm going to stop and I'll be right back. The settings, so I'll just leave it the way that it is. But the other thing that I want to mention here is, if you do have questions, please feel free to ask. So Foo Bear asked a little question here of no lag, but we're 20 minutes in. Feel like it's a Python lesson, not a Numpy or a Pandas lesson. I'm talking about floats and ints. You're absolutely right. I am talking about floats and ints. But I'm talking about floats and ints partly because there is a little bit of importance here about how it's managing the data types. but also as a nice little lead-in to this next little spot, which is the fact that we do have a lot of great tooling that's available to us with NumPy. So in the prior examples, what we did was we either hard-coded in some values or we went ahead and we just used an existing list. And so sometimes what we want to be able to do is just set up an array to start playing with. So there's a lot of great tools that are available to us with NumPy to be able to just start creating some items here. So you're going to notice that we've got the ability just to create a whole bunch of zeros inside of an array. So this is going to, in our case, be 10 zeros. Or if I want to go ahead and create a two-dimensional array, so a 3x5 array with a whole bunch of ones, then I can do that. Or if I want to fill it with some specific default value, then I could go ahead and do that. And I can even go ahead and specify either just a random set of values or specifically go with random integers, which in my case will be 0 through 10. So some really nice ways that you can go in and just start setting up some arrays that you can play with. Now, all of those are well and good, but wouldn't it be nice if we could go in and start creating some ranges? And there's actually two different ways that we could set up ranges. One is by using a range. The other one is by using this little linspace here. Now, I want to highlight that the parameters that I'm passing in here, the arguments that I'm passing in here, are identical. So in both cases, I'm doing 0, 20, and 4. And in both cases, the 0 and the 20 are going to set the lower bound and the upper bound. So they're both going to do the exact same thing. They're both going to go from 0 all the way up to, or at least try to get all the way up to 20. But how they get there is going to vary. So in the case of a range, what it's going to do is it's going to do it by 4. So if we run this, what you're going to notice is that we'll get 0, 4, 8, 12, 16, and you'll notice that we don't get 20 because it's going to be a non-inclusive. It's going to stop just before we get to 20. On the flip side, if I use linspace, what this is now going to do is this is going to set up specific groups for me. So this is going to set up 4 equally spaced groups. So we take the number 20 and we try to divide that up into 4 groups, again starting with 0 all the way up to, and in this case, including the number 20. And we try to break that down into 4 groups. Then what we're going to notice is that we're going to get really a third of the way there, the next third of the way there, and then the rest from there if you think in terms of like a fence post. So our arrange and our linspace are both ways for us to go in and start creating some ranges inside of an array. Okay, now I want to go in and start digging a little bit deeper into some of the different operations that we can perform on a NumPy array. So we're going to set up 3 different arrays, a 1-dimension, a 2-dimension, and a 3-dimensional array. Now you're going to notice here that we're going to set up a little seed here. And the only reason that we're setting up a seed is so that way we're going to get replayability. Typically, you're not going to set up a seed, but by setting up a random seed now, every time that I run this, I always get the exact same results. So it's really now sort of not random because it will always give me back the exact same values. The reason that we're doing this in this little demo is so that way when we get a little bit later and we start talking about indexing, that it just makes it a little easier to display everything out. And then as I'm running through this, I know what the values are going to wind up being here. Okay, so All of these are going to be integers because of the fact that we specified that we're going to be using a random int. And then what you're going to notice is that my three-dimensional array is in fact going to give me a three-dimensional array. Now, when I'm doing demos, I typically stay away from doing doing three-dimensional arrays. I really stick to 1 and 2, just because it's much easier to visualize 1 and 2. The moment that you start to get into 3, 4, 5-dimensional arrays, while yes, you will be working with those quite frequently, it's a little bit of a challenge at a beginner course, which is really what this is, to try and visualize what's going on here. But what is nice for a three-dimensional array for our demo purposes is the ability to see some of the information that I can find out about an array. So I can find out the number of dimensions, I can get the size, so the XYZ size, and I can get the total number of items that happen to be inside of there. So you're going to notice that we've got 3 dimensions. You'll notice that our dimensions are 3 by 4 by 5. And you'll notice that the total size is going to be 3 times 4 times 5. If you do a little bit of quick math, that's going to come out as 60. Now, we want to be able to go find individual items or groups of items inside of an array. So I'm going to use my little one-dimensional array here. Just going to print out the values. And I'm going to go grab that first item by using the index of 0. So counting everywhere, basically, starts with the number 0. So when I use that, then what you're going to notice is, sure enough, we get the number 5. That's the first value. If we use 4 here, then what's going to happen is it's going to go 0, 1, 2, 3, and 4. So in my case, this is going to give me back the number 7. Now, what I also really like about NumPy arrays is the ability to go backwards as well. So if I do -1, that will actually go grab me the number 4. If I do -2, that will actually go grab me the number 2. And so that way, I don't have to go in and start doing some bit of math around trying to figure out what my index is, my index -1, etc. Because if you're anything like me, and I know I am, I always get one-off errors that I cannot for the life of me properly do index math. I always get that wrong. And so it's really nice just to be able to go forwards or backwards inside of an array just by using positive or negative numbers just like that. Okay. Now if I'm using a two-dimensional array, so let's display out all of my values. Then I can do the exact same thing. So if I go 0, 0, that's going to be my first row, my first column, and that's going to be the number 7. If I go 2, 0, then that's going to be the third column and then the first row, and so that will give me back the number 8 there. Okay, so if I do 2, -1, then what that's going to do is that's going to count out to the third row and then go backwards from there to go grab that last number. So another way actually that I could go ahead and write this if I want to get the absolute last value, that's inside of there, would actually be to go -1 and -1. Now, if I go -2, then what you're going to notice here is that it gives me back the number 7, the number 7. And I want to pause at this moment here. Let me do this. So the question is indexing arrays are basically the foundation of Python. Not sure what NumPy is doing compared to the normal Python standard. And you're absolutely right that the main focus that I'm trying to get into here is the fact that my NumPy arrays do behave an awful lot like normal lists they do behave a lot like normal arrays inside of Python. But what you're also going to notice here is the fact that I will get some better performance. And you'll also notice up above that we were able to go in and do a lot of really neat things to be able to quickly populate arrays to go in and start working with. Okay, in fact, let me do this. I'm going to sneak down here just because I want to highlight a couple of very big things. Okay, so let's take a real quick look at some of the more higher level functionality, the bigger level functionality inside of our NumPy arrays. So quite frequently, what's going to happen when I'm working with data is that I want the ability to be able to start crunching values together. So I want the ability to maybe perform an operation to an entire array without having to loop through an entire array. Or I might have two separate arrays and I want to be able to add them together or be able to perform some form of matrix math across both of them. And this is where our NumPy arrays are going to come into play, is because they're going to give us that ability. And they're also going to be able to do this with much better performance. So you'll notice, for example, here that I can actually perform math on an array. So if I want to be able to add 5, subtract 5, multiply, divide, do floor division, do modulus, etc., then I have that ability. You're also going to notice that I have the ability to add arrays together. So I create two arrays here. I've got one with my values of 3, 6, 8, and 1, the next with 4, 5, 7, and 2. I add those together, and then what you're going to notice is that sure enough, I get those values then combined. So a really quick and easy way for me to start working across all the values inside of an array. Now, you'll also notice that there's the functions that are built off of NumPy directly, and you could go in and use them, or you can just use the little add syntax that you're seeing right here. But where things really shine for NumPy is when it comes to performance. Now, this is going to take it a few moments because it's going to run this numerous times behind the scenes. But in a nutshell, here's what's happening. Is we're going ahead and we're calling the sum function from two different places. So what you're going to notice is that this little function here, this is using the built-in Python function. And you'll notice that when that ran, it took 117 microseconds for it to perform the operation on just 1,000 values. That's it. But if I went ahead and used the Numpy Sum, so this is off of NumPy. Now, I don't know why I reran that. I didn't really have to, but that's okay. Give that just a second there. Now what you're going to notice is that this is going to take about 3 microseconds for it to run. So quite a substantial difference in the performance here. And there's a couple of very big reasons for this. One big reason is the fact that we don't have to do any type checking. That remember, in Python, Python is weakly typed. So while Python is going to store data types, it doesn't strictly enforce them. So it needs to figure out at runtime what my data types are. NumPy, however, is written in C. And for anybody who's programmed in C, you know that C is very specific about data types. So it's not going to be checking data types at runtime. At compile time, it's going to have the data types. It's going to know exactly what the data types are. On top of that, C is also a compiled language. Python is interpreted. So just inherently, C is going to run faster. So the two main advantages that we get out of using a tool like Numpy is we're going to get more advanced functionality when it comes to working across arrays, but we're also going to get better performance as well. And again, when you're working in data and you're working across large values, that little bit of performance is going to start to make a huge difference. And those types of more advanced tooling is also going to make a rather large difference as well. Okay, you can see all the different functions and so forth that are available to you, but sort of based on sorry, little calf cramp there. But sort of based on the chat window, what I want to do is I want to get into something that really kind of moves beyond arrays, and something that I think is really going to show off the power of a nice little library. And the library that I now want to introduce here is Pandas. Now, sadly, Pandas actually has nothing to do with the bears. I know I was very disappointed to discover that, but is really from the term of panel data. And what you're going to notice here is the fact that this was a library that was created by somebody else. And this is probably one of my favorite things about Python in general, is there's a friend of mine that likes to say that we're not launching rockets here. And the point that he's making when he says that is whatever it is that we're doing, somebody else has already done. And chances are somebody else has already built a tool that we can use, that we can take advantage of. So let's do that. Let's take advantage of tools that have been written by other people. And this is exactly what Pandas is all about. Now, the couple of main data structures that you're going to be working with in Pandas are series and data frames. So let's go in and take a real quick look here. I'm just going to import in both libraries. If you want to see the docs, then once again, you can do that with a real quick question, and I'll let you go back and kind of play around with all of that a bit later. Okay, now the first tool inside of Pandas that we want to play with is the series. So my series here can behave an awful lot like a list. Now, what you're going to notice here is that I created a series. In fact, I created it based off of a list, put in a few different values, printed them all out, and you're going to notice I've got 0, 1, 2, 3, and away we go from there. And you're also going to notice a little bit like a dictionary that I can access my values and my index separately. And you'll also notice, again, going back to like a list, is the fact that I can go ahead and use the exact same indexers, including my ranges, that I did before. Now, at this point, you might be thinking, hey, wait a minute, Christopher. Why is it that I might want to use this? I mean, you've shown us now NumPy array. You've shown us, well, just like normal lists. Why in the world would I be interested then in using a series? Well, the key is actually right here. And what you're going to notice is the fact that there is an index, and you'll notice that that's separate from our values. So it sort of hints at the fact that I might be able to manipulate that index, that I might be able to work with that index and be able to change it to be something else, to be able to create my own index. And so what you're going to notice is I can do exactly that. So I'm going to take the exact same values here. And this time I'm going to give it my own index. And so now when I go ahead and I run this, now what you're going to notice is the fact that I have that core little index over there that's now going to be based on letters rather than based on numbers. And then you'll also notice that if I print out my value here, that sure enough, it's going to print out, in my case, the second item. Now, there's two very important things that I want you to notice, because you might be now looking at this and going, wait a minute, Christopher, what's the difference between this and a dictionary? Because after all, in a dictionary, I can provide my own index, I can set up whatever values it is that I want, etc. And the example here is a little bit subtle. So I'm going to make it a little bit more explicit here. Oops, you're converting that into being numbers. That's fine. I'll leave you the way. Or no, sorry. I was right. I shouldn't doubt myself. There we go. Okay. So here's what I want you to notice. What I want you to notice is I went ahead and I ran this code and I put quotes around this 1. And I want you to notice right here this data type. And you notice that data type is set to object. Object being really just sort of anything. In this case, it's for string. What's happening here is the fact that I have now created a series with everything that's been upcast into being an object. So you'll notice that we've got a number, we've got a number, we've got a number, but I've also got a string. So everything is being upcast into being a string or into being an object, because after all, everything can be an object. Or if I take away those quotes, now what you're going to notice right down here is that everything has been cast to be a float. And you'll notice that that's true even with this -2 here, which of course is simply an integer. So just like with our NumPy array, everything is going to be a consistent data type. But unlike with our NumPy array, we have the ability to specify our own index. Now, you might still be thinking, well, wait a minute, how about this as compared to a dictionary? Well, it's worth highlighting the fact that we can actually create a series from a dictionary. But unlike with a dictionary, the order inside of a series is going to be guaranteed. Now, this is something in Python that is changing, that dictionaries are eventually going to have a guaranteed order in which the data is being stored. But as of right now, you can't guarantee that. Series does guarantee that. So as a result, I can actually then treat that index just like I would a normal range index. So if I want to go get one value, let's just go grab Russia, then I can get one value. Or if I want to go in and set up a range, then I can go ahead and set up a range. So you'll notice that I say Germany and Japan, do the full range, and then I get Russia in between there. If I happen to do something like this, I'm going to introduce an error. You're going to notice that I get no values back, because what it's trying to do is it's trying to go from top to bottom, from Japan to Russia. If we take a look at Japan, you'll notice that is at the bottom, so I'm not going to be able to get an index that way. So what we're getting here is really kind of a nice hybrid between a list and a dictionary. And so this is what our series is going to do for us. But if we're working with data, it's very rare that we're going to be working with just key value pairs. Sure, yeah, that's going to happen. But quite frequently, I'm going to be working with large arrays, which is where NumPy arrays come into play. Or I want to be able to work with some bit of tabular data. And that is where a data frame comes into play. A data frame, in a lot of ways, is like a relational table inside of my Python. So we already created our little population up above. I'm going to set up a brand new area here. That's what I've got right here. And I'm now going to combine them to create a brand new table or a brand new data frame. Now, what I want you to notice before I run this is this. Let me just print all of this out. So you're going to notice that I have Albania, I have France, I have Germany, I have Japan, and I have Russia. And if I scroll on up above here, that you'll notice that I've got everything up above, and we added in, let me make sure I add in Albania right there. So I've got France, I've got Germany, I've got Russia, I've got Japan, and I've got Albania. So I've got two separate objects here. I've got two separate series objects. And what I want to be able to do is I want to be able to treat these together just in the same way that I would a table. So I want two columns. I'd like one with my population, the other one with my area. And then I want a column here that's going to indicate the name of the country. And that's exactly what's going to happen when I use my data frame. So my data frame is going to take that and convert that into my tabular data. So the end result here is going to be Albania, France, Germany, Russia, and Japan over here as my index column. And then you'll notice my population and my area here. And there's a cool little bit of magic that's happening behind the scenes because it's seen the fact that inside of our population series that we had Albania, France, Germany, Japan, and Russia. Over here in our area, we had Albania, France, Germany, Japan, and Russia. And it went, oh, okay. We want to go ahead and create a data frame out of those. I see all of those unique keys. I'm going to go ahead and bring those together for you and set those up as IDs. And that's exactly what it's done here. There is going to be a recording available, yes. Okay. Now, just like before, I can continue to add in columns. So if I want to add in a capital, then I can do that. If I want to set up the population density by doing a little bit of math, then I can go ahead and do that. And if I want to go grab individual columns, then I can do that. So you'll notice that this behaves an awful lot like an array with my indexer, but again, it's going to be a table. So I want to go grab the area, then I go ahead and I just specify the area. Now, when you look at that, you might be thinking, well, wait a minute, Christopher. If I can access an item based on the column, and I know that the columns are going to be a unique key, when I go look at the rows, I go, hey, all of those are unique. Shouldn't I be allowed to just simply go countries, Japan in my case? Wouldn't that make sense? And so you're going to notice that when I try that is going to fail. That the indexer here that I use is going to be the name of a column, not the name of a row. So fortunately, I do have the ability to go grab an individual row. I just have to use a different indexer. And this is where that location indexer is going to come into play. This will allow me to go grab a particular row by just saying the name. And if I continue down that path, if I want to go grab an individual value off of a row, then I can say the name of the row and the name of the column. So I do have that same ability to go XY inside of my coordinates to go grab a specific value. Okay, so the question that was in the chat here is that population density. Are you adding that in as a predefined function, or what's going on here? So what's going on here is this little line of code right here. So what we're doing is I'm taking my two columns here of population and area, and I'm performing math on them. So if I just insert in a cell down below here, and I just print this out, what you're going to notice is that it's just running that calculation for me right there on the fly. Very similar to how we were able to take two arrays and perform math on those. I can perform math on two columns. And so now what we're doing in this spot that's marked as 26 is we're creating a brand new column here called population density, and then setting it to be that value. Now keep in mind that this is not dynamic, so there's no like magic here. It's not like in SQL where I can do a column that's really actually doing math on a couple of others. It's nothing like that. It's nothing fancy like that. It's just simply I'm calculating the value, which is kind of cool, and then creating a brand new column and putting in that value there. If I went back in and I say updated the population, then my population density wouldn't be correct. I would then have to go in and re-update that. Okay. Cool. Now, and in fact, that's exactly what we're seeing right down here, is being able to do that. All right. Now, the other thing that I want to mention here is the fact that we can actually access our data frame exactly as we would a two-dimensional array. So if I run my countries.values, what you're going to notice is, sure enough, there's an array. So if I wanted to go in and grab specific columns and specific rows, then I can do that based on the index values as well. And that's actually really helpful in scenarios where I'm loading up data, and maybe what I need to do is just get rid of a few columns or be able to focus in on just a particular couple of columns. That, let's say that I wanted to start performing some analysis on the area and the population. Well, if that's what I'm trying to do, having this extra string text in there might not be helpful. And so by using this little integer location here, what I could then do is go, hey, well, I know that those are the first two columns. I just want the first couple of columns there. Then give me all of the rows. And I can do it like that. So that way I don't have to punch in names or anything like that. I can just use integer-based locations. And speaking of being able to work with data that I've loaded up, it's also worth highlighting this little fact right here, which is the fact that I can write and read values to and from a CSV file. So you'll notice, for example, that I've now got a little call to CSV. What that's going to do is that's going to write our data out to a CSV file. CSV, of course, is just simply a comma-separated value file. And so if I open up that little file, and this is actually the file that I just created, what you're going to notice is that there is everything that we have saved out. So I could, if I wanted to, maybe give that first item a name. Let's call it name because I'm really creative. And we could also go in and add in some other country here. And I'm just going to punch in a few little values here. There we go. So I really don't care what the country name is, what the population is, the area, the capital, the population. I don't care about any of that. I just wanted to kind of real quick show, hey, I could have new values that are added into there. And now, if I come back over here to be able to read the value in, now what you're going to notice is that I have that new value down here at the very bottom. Now, I want to close off the loading of my data here by highlighting one last little item, which is you're going to notice that, unfortunately, it didn't pick up the fact that this is my index. Well, fortunately, I have the ability to specify all of that information when I go to load in my data. And so what I did is I just simply used this little question mark here to bring up my help. And you'll notice right here, there's my index column. My index column is currently identified as none. In my case, I want that to be name. So I'll just go ahead and say index column equals name. Whoops. It's index col. See, abbreviations get me every single time. There we go. Now you're going to notice that my name is set as my index. So it is possible then for me to be able to both save my data and to load my data. Now, as I said at the outset of all of this, and I see that I've got a couple of questions there, and I'll get to those in just a moment here. But there's an awful lot into using data frames. There's an awful lot into using our NumPy arrays. And so my goal today was really just to highlight a little bit of the basics and hopefully really just help to get you started. That from here, hopefully I've given you enough to be able to start playing with your own data, and then you can start to pursue some of the more advanced bits of functionality. So for example, one thing that's going to be quite common is that you'll be loading up data and there'll be some form of duplicated values inside of there, some form of corrupt values, etc., that you'll want to be able to modify. And so fortunately, data frames will give you that ability to start cleaning data, to start, say, loading up value from two separate CSV files and joining that together, performing unions, etc. So there's a lot of great power that's here. And again, my goal was really just to try and show off some of the basics, which hopefully you've picked up from here. Now, as Megan mentioned in the chat, this video will become available on YouTube. And I also want to highlight that over here on github.com/reactors, /Microsoft/reactors, that everything that we're going through is inside of here. In particular, this was all inside of the Data Science 1. There we go. And you can go in and check out the notebooks and everything inside of here. So if you want to be able to go in and play with that all on your own, you can go ahead and check that out. So with that, let's see, a couple of questions that are in here. How does it guarantee the order when a new column is populated? Is it the order of the indexes? Are you talking about inside of the CSV file, or are you talking about inside of the data frame itself? That in the data frame itself, it's going to be the order in which it was added, but you also do have the ability to use different bits of functionality to move columns around. So that way, if I want to, say, either just get rid of columns, I can just drop them, or if I want to move them, change the index of them, I do have that ability as well. But by default, it's going to be the order in which they're populated. The next column will just go at the end, go at the end, go at the end, go at the end, etc. Can I mention panel or multi-dimensional frames? I'm going to openly admit that's above me, above my pay grade. I unfortunately don't play around enough with that to be able to answer that question. When I select a column or multiple cells, you don't just get the array of numbers, you still have the index in a dictionary. So some operations won't always seem to, is there a way to work around that? Yes. So the question is there a way to not have the index be returned? Yes. Now, the question is how to do that. I know that it's possible. I just can never remember how. I don't know if Megan's still around or if maybe Sarah's connected. They might know the answer. Let me do this. Yeah, I know that it's possible. Unfortunately, I just don't remember off the top of my head. You can hit me up on Twitter. I'm Geek Trainer on Twitter. And I'll be more than happy to answer your question there. It is possible. I just cannot for the life of me remember how to do that. Yeah, I don't remember. I apologize. Cool. Okay, yeah. Yeah, and it is the underlying C++ that's maintaining the order for me. That question mark notation is cool. Yeah, so I want to highlight about that question mark notation that this is not something that is particular to pandas, but rather to Jupyter notebooks. So if you try this in just like a normal Py file and then you run that, that's not going to work. But if you are doing this inside of Jupyter notebooks, you can do that question mark, and then it will give you a lot of great information about that. It actually just pulls out the help information for you. So pretty slick. Cool. All right. Well, with that, I want to thank everybody for connecting, taking a little bit of time out of their Tuesday and or Wednesday. We are going to be back online on Twitter tomorrow, doing a little bit of live Q&A, and we are going to be broadcasting again on Thursday morning. So definitely do check us out. And with that, I want to thank you all very much. Bye-bye.